Hey guys, how's it going? Melody here. Welcome to today's video where today I'm gonna show you guys the game that I made in C. So here's the source code for the game. It's a console based game. It's a really simple game. It only works on Windows. Okay. So yeah, this is my attempt at getting good at C again. So I'm really rusty at C right now. So this is my attempt at becoming really good at C again. And I'm hoping to learn more than I knew before about C. So yeah, so this is the attempt to get good at C again. Because I did game development at the university, this part I just directly copy pasted from one of the university assignments. Yeah, from one of the university assignments, I just directly copy pasted it. The university uses C++. So yeah, this is from C++. I just copy pasted this from a C++ project. This is for movement, so it's the same movement code. Like it's the same like movement keywords and stuff from the C++ assignment from my university, right? Because I've already got the movement thing in there, the syntax and everything. So instead of like trying to research movement syntax, I just copy pasted the entire syntax for movement from the C++ folder onto this one, okay? Onto my into my snake game, okay? So yeah, that one just works by defining VK up and all of that, and then you have to do this one, get key state VK left is lesser than 0 to check if the key is pressed. But other than that, yeah. So why using Ansi C89? As you can see over here, this is C89 and CC. So yeah, we use stdioutime.h and windows.h, and then we define the input values, right? And then we have int main. What happened there? I have two laptops on, by the way. Int main, and then we seed rand, okay? We seed the rand function with time 0 at the current time to make it truly random, I guess. And then we have the screen. This is the screen, by the way, the whole display 20 by 50, right? And then we set everything as grass. And then, yeah, and then we have int apple is the position for the apple. And then we put an apple in that position on the screen, as you can see. And then int size is equal to 1. This is the size of snake. And then we have the snake array, which basically stores all the position of each body part of the snake. And then we have temp, as in temporary. We all know what temporary means in coding, right? So int head is equal to 0, tail is equal to 0. Why do we have a head and a tail? And then int ink or deck is equal to 0. Well, because we're using a circular queue. The thing is that when you use circular queue to handle snake logic, your code is computationally more efficient, right, in terms of time. So in terms of like the big O notation, this is O of 1 in terms of big O of time if you use a circular queue. So head marks the head of the queue, tail marks the tail of the queue, and ink or deck stores the what do you call it, what type of tail movement we're in. Okay, it had been really long since I'd learned circular queue, so I had to rederive how to implement circular queue using my notebook. And so from my notebook, I noticed that there are two possible states for circular Q. One where the head takes the tail, right? Head is equal to tail. And the other where one where the head, obviously in both of them the head is equal to tail, and it's the tail either increments or decrements based on what state, what like type of circular queue you're in. Okay, what state of circular queue you're in. So yeah, I noticed that from my notebook. So yeah, uh, uh but basically, let me. Oh, I don't. My notebook is in my bag. But basically, it will make sense later on. Okay, it will make sense later on. And then snake 0, 0, the snake's head's position, right? Obviously, initially the head and the tail are both 0, and then y is equal to 1, and then the rest of the snake body paths are at 50. So this is to nullify them. Yeah. I don't think this is important. This was part of the previous logic where I did not use a circular queue, so it had to iterate through each body part. And so to terminate iterating through each body part to handle collision and movement logic and all of that, in order to terminate it, I used this. So yeah. But I don't think I need it anymore. I don't think I need that anymore. And change this equal to 0. This is for when snake eats the apple. Okay, we store the state in changed, and then direction is equal to 0, 0 for now. Obviously, that is equal to 0. Screen snake. Obviously, we put the snake into screen, and then if not that, then movement logic, change that direction based on the input key and the previous direction, right? So if the x-axis direction was not 0, we are not allowed to alter the x-axis direction, right? So it cannot be like if the snake is going right, all of a sudden the snake goes left. You cannot do that in the actual snake game, otherwise you'll walk onto your own body parts. But yeah, right, so that's that. And then changed. So if an apple is eaten, change this equal to 0, obviously, to make sure it does not loop through this if statement again and again and again. If block, and then if size is equal to 3 and head is equal to 0, encodec minus equals 1. Else if size is equal to 3, encodec plus equals 1. Okay, this is important because from my notebook, I derived that when the snake was at size 2 and then it increases to size 3, I noticed that the head position, where the head is, whether the tail is gonna increase or decrease later on is gonna depend on what the head position is when we increase from size 2 to size 3, right? So if the head is in position 0 and we increase the size from size 2 to size 3, encodec needs to be minus 1, which means that we decrease the value of tail, and then obviously loop around when tail is equal to minus 1, we just loop around, right? Otherwise, if head is equal to 1 and we increase from 2 to 3, then encodec needs to be plus 1, so it means that the tail's value increases. Okay, and then in temp we store the location the next head needs to go to. Obviously, the location the next head needs to go to is current head's location plus direction, right? Current head's location plus direction is the location the next head needs to go to, right? So we store that in temp, and then head is equal to size, and then we change, because otherwise we cannot, we need to store the current head's location plus direction, because if we change head, then we need to access the previous head again. So we store that in temp first, and then only after that we change head to, size -1. Obviously, this is when apple is eaten, so size increases when you eat an apple. So the new head is obviously the new body part, which is obviously at size -1, the index size -1. So snake, and then the new body parts look coordinates are temp. Okay, the new body parts coordinates are temp, and screen snake, and then put that snake body in there. Yep. Otherwise, if did not eat an apple, if the snake did not eat an apple, right? Take the current tail position, turn it to G, right? And then temp, take the head position plus direction, store that in temp, and then head is equal to tail, right? Because we are moving. Because how the circular Q snake works is that for moving, you just take the tail and put it in front. Take the tail, put it in front. Take the tail, put it in front. Right? So that's what we're doing here. Right? So we're taking the tail. So head is equal to tail. And then we're putting it in front of the previous head. Right? Based on the direction of what is considered as front is dependent on the direction, as you can see. And then if screen, and then before we print this, the movement, what we need to do is check if there is already an S there in that thing, right? Before we put the new head location, before we put the new head location in the screen array, we need to check if there's already an S there, a body part there, right? Because if it is there, then obviously that is equal to that, because you're colliding with your own body if there is already a body part there. So that's why we don't immediately do screen snake head 0 is equal to S. We check if there is an S already there. If it is not there, then we can put an S there. However, if an S is already there, then if there is already an S there, right, then it's collision with the body part, so that is equal to 1. If not, as you can see, we put an S there now, right? So yeah, that's the thing. Also, it checks out of bounds as well, so X is lesser than 0 or greater than 49, or Y is greater than lesser than 0 or greater than 19. That is equal to 1. Otherwise, just put the new head location there, right? And then if size is equal to 2, equal to 2, right? Tail minus tail. If size is greater than 2, tail plus equals encodec, right? This is where that is important. And then if tail is equal to -1, then we loop around, right? Because it's a circular queue. Else if size is tail is equal to size, then loop around, right? So based on if you're increasing, obviously it's gonna be size eventually. Otherwise, if it's decreasing, it's gonna be -1 eventually, right? So if snake head 0 is equal to here we check the collision with an apple. If it collided with an apple, we change the location of the apple, and we don't have to do location of the apple and screen is equal to G, because snake's head is there, so we put an S over there, right? So over here we put an S, already, so we don't have to like remove the a from there, and then change is equal to 1, and then plus plus size, and then screen, um put the new apple on the screen, and then and then we print the new screen, right? We're printing the new screen here, and then in here, if that is equal to true, as you can see, printf you died, enter 0 to play again. I meant to say play again. Enter 0 to play again. If not, press anything or ignore, right? And then scanf percentage %d and %that. If not that, right? If that is not true based on the input, then direction is equal to 0, and then it resets all the values, right? So y is equal to 0, and then reset all the snake values, right? And then yeah, if not y, right? So if y is equal to 0, that's obviously the head. When you reset the values, else. I don't think I need this part over here. I don't think I need this anymore. But yeah, the size is important. The array is still important because you have to reset everywhere the snake's body is. You need to turn all of them to grass again. So yeah, size is equal to 1. And then we only do size is equal to 1 here because the size of the entire snake is important over here to reset. And then size is equal to 1, head is equal to 0, tail is equal to 0, encodec is equal to 0, screen, put the apple on the screen. Remove the apple from the screen here. Remove the apple from the screen and then get new apple coordinates and then system CLS and then return 0. If you're curious of what that looks like, right? If you're curious about that, let me show you what that looks like. So, here is the game, okay? That's the game right there. Let me make it clearer for you guys. Yes, it does have flicker. Okay, it does have flicker, but it works. Trust me, it works. Okay, so I can do something like, oh, yes. Oh, ooh. Yes, we win these. Come on, I'm a pro gamer. Come. Oh, fuck, dude. Come on. That was close. I hope. Oh, that's yeah. Oh, fuck. I hit the corner and I dodged the collision. I dodged the out of bounds. That's actually insane, dude. Not gonna lie. Oh. Oh, fuck. I went out of bounds. Okay. Yeah, I became skilled at this game over time playing it. While playtesting it, I became kinda skilled at the game, dude. Not gonna lie. I'm a pro gamer, dude. I've always been skilled. What do you mean? I've always been skilled, dude. Fuck. Hold on, let me lock in. Hold on. I'm a lock in now. Fuck. Okay. Also, I've made snake multiple times before, but this is my first time using a circular queue in snake. I just never thought of the circular queue idea before. Previously, I just used arrays, and there was this one time when I used the linked list, which I know is computationally horrible. But yeah, this is my first time using the circular queue to make the snake. I just I just thought of it while making this project. I had already finished this project using my usual method of looping through the entire array of snake bodies, right? So obviously that's bigger of size, right? Whatever the snake's size is, that's bigger of size. Looping through the entire array of snake bodies. That was my previous solution, and that's the one that I always do, right? And then after I finished that, I immediately thought, hey, why don't I use a circular queue? Like, that makes sense. Why didn't I ever think of using a circular queue? So this is my first time making snake using the circular queue method. Yep. And that to rederive how to implement the circular queue, I had to derive that again. So I used my notebook to derive how to implement the circular queue for my snake game. Yeah. Fuck, dude. Yeah, it does kinda get harder when the apple is close to the boundary. I know it's kinda hard to see because of the flicker. I'm gonna solve it later, okay? I'm gonna solve it later when I become less rusty at sea. Okay, when I become better. I'm probably gonna use a better updating technique, like the screen updating technique. Yeah, sometimes it does that. Oh fuck, I wasn't. I was stimming, dude, I was stimming. Oh. Okay, sometimes it does this. I don't know why. But yeah, I'll see you guys next time. Until then, bye bye.